Hello students, welcome to Show Up Sir's classes. So in today's video, we'll solve questions from mathematical statistics. So the question goes like this: from a finite population of n animals in a given region, we are caught, marked and then released again. The animals caught again one by one until m marked animals are caught. The total number of animals caught is a random variable x. Now we have to find the probability of capital X equals to small n for n lies between small m to capital N minus w plus m. So how do we do it? For this, first we have to write down p x equals to n equals to p, which is catching n minus 1 animals of whom m minus 1 are marked. So we have found that p probability x equals to n equals to p catching n minus 1 animals of whom m minus 1 are marked. Now from here we can write which is multiplied with probability of catching the marked animal from the remaining n minus 1 animals. So we can simply write it this way. Now from here we can write, if you put the values that we have found here, it will be equals to w m minus 1 n minus w small n minus small m divided by capital N small n minus 1 multiplied with this thing, which is w minus m minus 1 divided by n minus 1. So we can simply write it this way. So this is nothing but, if you solve it, you will get it to be capital N minus small n, capital W minus small m, capital N minus 1, m minus 1 divided by n w. So if you do it, we'll get it to be like this. So for this question we had to show this. So we have solved this question. So first I will ask you to go through a question once for a couple of seconds, then we'll again repeat the answer. So the question grows like this: from a finite population n animals in a given region, we are caught, marked and released again. The animals are caught again one by one until m marked animals are caught. The total numbers of animals caught is a random variable capital X. So we have to find the probability capital X equals to small n for m less than equals to small n less than equals to capital N minus w plus small m. So for this we have written the probability of catching n minus 1 animals of whom m minus 1 are marked multiplied with probability catching the marked animal from the remaining n minus m minus 1 animals. So from there we can write it this way. So we have found the value to be equals to this. So in today's video we solved a question from mathematical statistics this. So in the coming videos, we'll solve other questions from mathematical statistics. We could not get into the nitty-gritties of this area. So if you want to know more about it, I'll be giving you my number, which is 983679 3076, or you can also go to our website, which is www.saurabhsirclasses.com. There you will find a lot of other videos like this, and you will also get to see a lot of other materials needed to mathematical statistical questions. So thank you, we have solved this question. Now we'll go to our second question. So the second question goes like this: an urn contains m balls numbered 1 to m, where first k balls are defective and the remaining m minus k are non-defective. Now a sample of n ball is drawn from the urn. Now let ak be the event that sample of n balls contains exactly k defectives. Now we have to find the probability of ak, that is the event that the sample of n balls contains exactly k defectives when the sample is drawn, 1 with replacement and 2 without replacement. So first I'll ask you to go through this question for 1 minute so that I'll be able to solve it. You will get then. I hope you guys have gone through the question. Now I'll write down if the sampling is done. For the first question we'll write if the sampling is done. The first is with replacement, or say first we'll do without replacement. Then we get hypergeometric probability. Then we get hypergeometric probability model. So which looks like this: probability AK equals to K small k into m minus k small n minus small k into, it will be divided by capital M minus small n. So we can write it this way. So first answer we have written without replacement. It will be hypergeometric probability model. So we get this. Now before we go to this question, first go through it for a couple of seconds. So now we'll go to the second question, which is with replacement. So what happens with replacement? So if you take, rather it was question number 2, we'll do 1. So in case of with replacement, then capital X belongs to binomial n comma p, which is equals to k by m. Now hence probability ak in this case becomes equals to small n small k by m to the power small k into 1 minus k by m to the power small n minus k, which is equals to nk into capital K into small k, small k, m minus k to the power n minus k divided by m into the power n. So we get this value. So in today's class we have solved this question, that is an urn contains m ball number 1 to m, where the first k balls are defective, the remaining m minus k are non-defective. A sample of n ball is drawn from the urn. Let ak be the event that the sample of n balls contains exactly k defectives. So we had to find the probability of ak. So we have done this too with replacement and without replacement. In case of without replacement, we have found it would be a hypergeometric probability, and with replacement class it will follow a binomial n comma p equals to k by m. So thank you for watching this video. In today's video we solved 2 questions from mathematical statistics. In the subsequent videos we will solve other questions from related to mathematical statistics. If you have any query or doubt, or we could not get into the nitty-gritties of it, so if you want to know more about it, I'll be giving you my number, which is 9836793076. You can simply WhatsApp me on this number, or you can also go to our website, which is www.showdopsersclasses.com. There you will find a lot of other videos like this, and you will also get to see a lot of other materials which are needed to crack various exams related to mathematical statistics. So thank you for watching this video. Have a nice day ahead.